Hi, today's lesson is on solving problems with waves. It's specifically light waves, and we're going to look at their energy, E, their wavelength, and their frequency. So go to problem book page 225 and follow along. Pause the video and come back when you have it ready. Don't forget a calculator too. So at the top of 225, you have two equations, but I want you to add one more. So you have the C equals lambda times frequency, which is the speed of light equals the wavelength times the frequency. You also have at the top of the page energy equals Planck's constant times frequency, but you don't have this third equation, which is just a combination of these two. So as you can see, instead of having the frequency, it replaces that with speed of light divided by wavelength. So add this to the top of the page. And it also gives you Planck's constant, which is 6.63 times 10 to the negative 34 joules per second, and it gives you the speed of light, 3.0 times 10 to the 8 meters per second. So how do I go about solving these problems? So let's do 15E together, and you can follow along with me. So let's read it. How much energy is possessed by a photon of light whose wavelength is found to be 3.6 times 10 to the negative 5th centimeters. So the first thing when I read this problem, I have to figure out which equation am I going to use. Am I going to use the first equation, the second equation, or the third equation? So it says how much energy, so I need an equation with energy, is possessed by a photon of light whose wavelength is found to be this number. So I have to find an equation that relates energy, which is what I'm solving for, and wavelength. And that happens to be, there's no energy in equation 1. There is energy, but no wavelength in equation 2. So equation 3 is the one I'm going to use for this problem. So the first thing I'm going to do, like you would on a test, is write the equation. So E equals hc over lambda. Now, anytime you have an equation with both the speed of light and wavelength, one thing you need to do before you start the problem is to make sure that the units for distance are the same in both the speed of light and wavelength. If we go back, we see the speed of light is given to us in meters per second, but the wavelength is given to us in centimeters down here. So we have a problem. We're going to have to convert, and I'll convert the centimeters to meters. So before you start, you need to check, do you have units that will cancel each other out, or do you have ones that you need to convert first? So look at your wavelengths if you're doing a problem with wavelength. If it's not in meters, go ahead and convert it to meters first, and then solve the problem. So I'm going to do that conversion first. So it's given 3.6 times 10 to the negative 5th centimeters. And hopefully you remember your conversion factors, but there's 100 centimeters for every 1 meter. And that gives me an answer of 3.6 times 10 to the negative 7th meters. So notice it's really just moving the decimal place over 2, and the answer is 3.6 times 10 to the negative 7th meters. So now I have that, and that's my wavelength value. I can go ahead and do the next step, which is substitute. So energy equals Planck's constant, which at the top of the page is given to you as 6.63 times 10 to the negative 34th. And the units are joules seconds. So that's a times, joules times seconds. And then the speed of light is given to you at the top of the page as 3.0 times 10 to the 8th meters per second. And the wavelength, which we just calculated in meters, was 3.6 times 10 to the negative 7th meters. Now, if you go ahead and take out your calculator, and don't forget to use that EE button, because we have a lot of exponents, and if you don't use that, you often get the problem wrong. So don't forget to use that button. So if you plug this all in, you get an answer of, and we're going to round it to 2 significant figures, because I have 2 significant figures for some of these. And you get 5.5 times 10 to the negative 19th. And then I have to figure out what units I have. So seconds cancel, meters cancel, and I'm left with joules. So 5.5 times 10 to the negative 19th joules. And there you have it. So what is the trick or process in solving these problems? One is you have to choose the right equation. So that's my first step. I chose the equation that had the variables I wanted. So equation 3. Then check your units. If you have wavelength, make sure they're in meters. After you got that, substitute. So I plugged in the values. The next step is to solve it. So get out your calculators and use the EE button. And then at the end, make sure you have the right sig figs and the right units. So go ahead and give those problems on 225 a try. And if you have questions, ask them in class. Thanks for listening.